All right. Good evening. So I'm gonna just walk you through kind of a cool innovation that I've done recently with Claude, and then I'm gonna walk you through some new stuff. And so, yeah, I'm kind of excited for tonight. We're gonna talk shortly, like just a little bit about BlackBerry and some of the stuff, because you guys know me as a BlackBerry guy a little bit, and then I'm going to talk about AI and agents, and we're going to dig into a bit of an operating system that I've been building for working with agents because I think that's the future of modern dev. And my background, I'm trying to figure out which direction is dev going. Programming fundamentals are really key. I'm thinking about teaching that more mainstream. Um, I see there like learning to think like a programmer teaches you how to you build context, build systems that matter. I think AI is super good at building you a complete system, but there's a situation I always enter in where I'm working with students and I say, okay, go build this. And they use the lowest quality model and then they go and build it and they fail. And then I go and do it. And I show them, okay, this is how you engineer context. And I'm always trying to flush that out. Like, what is that piece? Is it just XP? Like, is it just experience or is it something more? So anyway, we're going to talk a little bit about that today, but quickly, let's jump into Claude on the BlackBerry Passport. So this is my uh, BB10 device, my Passport that I'm streaming here. And so somebody reached out in the community and they said, "Hey, Matt, I think I got Claude Code working for your Node.js runtime." So I took a look at it and then he told me what he did, and then I said, "Well, I'm going to try and do it myself, and then we'll share, our successes." And so yeah, I got it deployed. It's pretty neat. So this is running on the Passport, right? It's Claude Code because I have Node.js, and I'm using their package, and yeah, it's really neat. So I can say like, create me a Note uh, app. Single file, Python, um, on port, I don't know, we'll say port, 5006. Okay. And what's neat is that, of course, being an agent on your phone, it's going to run and it should execute the code locally. So hopefully it passes the test here as I'm streaming it. But yeah, so that was a neat project, and this kind of goes back to one of the points that I had a while ago, where I'm like, this is the future of phones. I think we're getting away from apps, and we're just wanting a prompt interface. We're just wanting an agent to talk to do this thing or that thing. And I've really been like on that one. Do you want to create the Note app? Yes. I've been really on this mission since I started the channel, really like saying, hey, like this is the way it's going. BlackBerry should come back and offer a generative OS because and hardware because everything's gonna be generated. Apps, software, these things aren't as important. I mean, when X and Facebook locked down their APIs, I mean, yeah, you know, but if you have Chrome, you have the browser, you have Chromium, well, then you can get past that, right? So I think apps are losing their value. Software is losing its value, and BlackBerry is best to pivot back into hardware ASAP with the hardware that can run models that are tuned for it. And so that's my advice to BlackBerry is you better pivot into this space because your software is having less and less value every day. I could go and fire up Minix 3, which is it's a same kind of infrastructure as QNX. And I could start compiling software for Minix 3, which has a lot of the same advantages as QNX. And that effort is no longer nearly complex as it used to be, right? So anyways, that would be my word to BlackBerry is software is getting cheap really, really quick because of what's going on with AI. And so I'll just show you this little note app we generated here, right? So my idea of the future of the phone, you load up your phone, it has a built-in model, a built-in agent, so I don't have to use Claude Code. Um, Wait, is that what I use? Port 5006. Did it run it? Let's say installation and running. So it says it's running. Local host, though, maybe that's the problem. I notice that Python sometimes it's very specific. Doesn't look like it's running, Claude. You're lying to me. So I'm going to exit and then I'm just going to run it manually. Python 3 note app.py. See if it runs. Okay. Good sign. Good sign. 127.0.0.1.5006. What do we got? It's thinking. Must be a crappy app. But I use Claude Haiku because they charge so much for Claude Code. So, anyways, but yeah, I thought I'd just demo that really quickly. Hopefully the app runs. I don't know if it's just being silly. Maybe I do need to use my local host or 0.0.0 is the safest one usually when, yeah, there it is. Okay. Note. Hey, hey, click the button. Does it work? Maybe it does, maybe it doesn't. Maybe I forgot to say for ES5 compatible browsers. I'm sure Claude wouldn't have known that from the start, but that's okay. So Claude Code running on the BlackBerry Passport, kind of a cool trick. And I'll keep, hammering away at this project. I still use the Passport for a lot of my, mobile dev workflow, and that doesn't seem to be stopping, even though I really, kind of want a better device for that, but it's still the most versatile. So the idea here would be, transitioning, mobile agent all there. And you can kind of do that. I was reading about there's some apps now in Android where you can like run the model on the phone and then host it, and you can use your phone as a model. That's pretty cool. Those phones though that can run those models, I mean, that's expensive too. So I'll be careful about that. So I'm going to dig into kind of a topic that's really big to me. It's not BlackBerry related, but it's very much related to the world of AI and dev. And I read an article recently, 2 days ago, that Google released something called Google Skyon or Skyon, and I read how they were doing it. I was like, holy smokes! I mean, that's the exact same way I've been doing it. And so I'll walk through this kind of agentic workflow, the software that I was making in order to like make it so that I could, you know, get better at managing agents. So I often tell people close to me, I said, I kind of envision myself playing StarCraft. And, you have all these drones or SCVs and you're like patrol and you go there and the agent, the drone does its thing. It has its abilities. It goes and mines a thing. And there's this automated workflow that's as simple as clicking, P on the keyboard and then patrol or mine or gather. And it just goes and does this thing, kind of like a routine. So I started kind of approaching what I built with that mindset. Like I'm playing an RTS, I got 200 units. How do I control them all? And what are their abilities? And so I really dug into it. And one of the things that I think, a lot of us started doing in the beginning was we got Cursor or we got Copilot, right? And we got it online and it's working pretty good. And one of the things that a lot of people do that maybe is a little bit different than what I do is they open up Cursor on their computer and they open up a directory. And because I've got such a DevOps background, I wasn't actually doing that. I was opening up uh, servers through the remote SSH plugin and then connecting, Cursor, the IDE, to these remote environments like this, right? So I go connect to host. I'll pick like my BB10 Docker tool chain for dev, and oh, I got to share a different window. Apologies. Um, just share the other one here. And so I would connect with Cursor to the system, right? And I would then begin using the system, like using the agent inside the system. And I'd say like, hey, can you know, check the disk space or whatever it is, and the agent would do it. And so I would start, building and managing a lot of the code that I was running and writing. The agent would directly write that code on the machine, and it was contained, and it was a great workflow, right? So the challenge though with this workflow is that you have these agents, these context window, um, that I have to type in, or I can use Whisper. Check out Whisper if you don't have it. I can say like, "Hey, can you write me a test hello world file and dot text?" And, then it appears, I hit enter, and it just goes and does that. And so we use the agent in the IDE, and this became a very popular workflow for probably a lot of devs in the last year or two. I know it was for me. But one of the challenges of it is like you think about agent orchestration. You think about, well, I want to give this agent a routine. I want to tell this agent to do something and make them smarter. And there's a couple big knowledge gaps that maybe precede this kind of talk that, about building context files and injecting context into your conversations before you start working. And these are all kinds of natural evolutions of working in this environment that maybe I should talk about, prior to digging into this. But I think you can grasp the concept is that if I have one window and one agent, I can't tell this agent to, send an instruction to another agent, um, and I can go up here and I can create another conversational thread. But there's this kind of awkwardness about like, okay, can I get this agent to send an instruction to this agent? And, how do I organize and how do I like manage all of that communication? And so I hit these limitations, I hit these limitations. I was like, I have, 20 cursor windows open, connected to 20, virtual machines, and I'm, managing all these windows and these conversations, and it's working, but it's slow. There's something wrong about it. It doesn't feel efficient. So then we enter the world of like open code and like CLI-based agents. And this really was like something where I was like, well, this is interesting. And so I'll just kind of show you what this means to me is that, here's a terminal on my Mac, right? And I load open an agent like this. And now it's the same thing as cursor, but it's in the command line. Okay. And I'm like, okay, well, this is kind of neat. Like, so at first I thought it was actually worse. Like, my first inclination was, well, this is terrible. Like, why would I do this? Like, there's no GUI, there's nothing. But I was thinking very much like, graphic user interface. But every time you think about you have a graphic user interface in the way, you either pay a lot more for inference and you fill up context length. And we want to get rid of GUIs when we're talking about operational efficiency. And I always give the example. Do you think people are going to write Word docs in the future? No, they're going to write .mds, something to generate code. And it's simple, easy, but makes documents beautiful, right? So I don't write proposals with docx because I have to buy Word. Why would I do that? I write proposals in .md because AI can generate it, right? And so GUIs are often in the way once we dig into like efficiencies. So let's say I have an agent over here and I say hi, and the agent, says, hi, what would you like to work on today? Okay, well, that's interesting. But what if I open up another terminal, right? So I got into this situation where, sorry, I have to like reshare the screen here because it's just the way it is. So share portion. So I started thinking, well, okay, maybe I have an agent on this window, right? And then I have an agent on this window, right? And this is where I'm like, well, I'm still having the same problem. Like, how do I communicate? How do I make the agents communicate? Like, I can't say to this agent, send a message to another agent cursor session running on the Mac, right? Like I can't do that efficiently. There's not a mechanism for me to do that. And so I start researching like how do I do this? How do I do this? And this is what leads me to a multiplexer. And a multiplexer is kind of interesting. What it does is it basically creates windows. So if I go into here and I create a couple different windows, I'll show you here. So we'll go into one, I'll do Control B, C, Control B, C, Control B, C, Control B, C, and then Control B, W. And now I have all these like different terminal windows that are open, right? That give me the ability to like uh, communicate. And then and then as I dug into it a little bit, I realized that with these different windows, I could actually send commands to and from the windows. And maybe I can demonstrate that a little bit. Um, and come into another window. Let me just get the code here for you. Um, I have an agent system I will show you, but this is kind of what the code looks like, is that I could send, so it says tmux send keys dash t, pick your window and your command, and then send it. And then I realized, oh, crazy. So if I used a multiplexer and I taught my agents how to use it, they could send commands back and forth. And this gives me, the human, an ability to like see what this agent is doing and this agent is doing. So what my theory was okay, I'm going to fire up an agent in this command line. Okay. And then it fires up. And then I'm going to go control BW. I'm going to switch to this one. I'm going to fire up an agent in this one. And and then control B and then do this one and fire up an agent in this one. And so I would have like three CLI-based agents now running with all these different windows that I could pop into, right? So that was the basis of like me figuring out, okay, if I'm going to orchestrate AI, this is one piece of it, is how do I make it all work in a way that the human can still control, and then you know, build out something manageable. So that's what I did. So then, fast forward, a couple weeks, this is what I built. And so now you know a little bit of how it functions in the background. This is just a fancy GUI where I still envision myself playing StarCraft or WoW or something and controlling, agents. And so the idea is, I have this dispatch and I can mention an agent and I can say, can you build me a basic single file Python website for a pet store? Okay. So I dispatch that command to one of the agent. I have this software made so that it opens up this window. Now it looks like, did I cancel this agent? No, it should be there. Yeah, it's there. Okay. Just making sure. Kind of popped into this too quick. And so the idea is I can dispatch, this command to an agent, right? And so it's agent test two, and we're on the wrong pane, of course, but that's okay. Let's go into here. Right. And so we dispatch the commands to all these agents, but really what these agents represent is two things. A tmux window. Okay. So behind this little draggable software. Well, actually, let me step back. So I talk about tmux. I'm using Cursor right now as the CLI-based agent. I can use open code. I've already thought about how to deploy agents and all the different things. They all work the same. But in order for this to work, I have to build context and then inject that context at page load or at agent load. So basically, if I fire up the terminal thing again and I do this, so I'm going to exit out of this. I'm going to cd Jarvis v2, and I'm going to go read. I'm going to fire up agent, but I'm going to say read context.md. Okay, when the agent boots. And when the agent boots, the first command it gets is to read the context. And this is where all the instructions of the agent lie. So it's like, you are Jarvis, you're part of an autonomous agent system and blah, blah, blah. So this one context file includes all the instructions, right? So now if I go and let me do it again. Let me fire up another one. I say cd Jarvis v2 read, so by agent read context.md. Okay. And I'm just going to ask, what is your session or identifier uh, for tmux? Okay. And I'm going to say, what is your identifier for tmux? Okay, let's see if I'm going to say run everything. It's going to ask me that. Okay, we'll see if this gets anywhere. So there's the values of it. So I'm just gonna demo this. I'm gonna say on this agent, I'm gonna say, can you send hello to session 3 index 3 tmux-s here. And we'll see if it does it. It might not. I'm kind of just spitballing this as I go. But what should happen is it's listing out the pane windows of tmux. It's got all that context that I injected it within the agent, and then boom, there it comes. So this agent sends that agent a message, right? And so that's one part of it. But how I was able to get that ability was I have one context file. I boot up the CLI-based agent with the context file. So the agent knows how to communicate and it understands its context. Now, the cool thing about that is I'm only using 6.2% of the context length. Again, some of this knowledge might be over your heads. I apologize if it is, but if you maybe get where I'm coming from, I'm basically using just one file now, a context document, to boot up an agent that understands what to do. It understands its place, right? So that's the premise of Jarvis. Okay, that's the premise. Is when I go into my dashboard or agents, and I'm going to say I'm going to do a new general agent. I'm going to say test, and I'm going to say agent backend is this, and then I hit deploy. Um, the idea is that agent is going to show up here, and I'm going to be able to there it is right here, give it instruction and so forth, right? So that's the idea of Jarvis. And and through this whole part is what happens is now I've got like an actual operating system. And I'm going to talk about what I mean by that. So imagine an operating system is just a single thought, like a single context document. So if an AI language model is smart enough to understand 256,000 words or tokens, you can give it a lot of context. You can give it, instructions. And in those instructions, you can lay out a system. And if you repeat that system, then you're going to have, basically an operating system that's classified as just one single file. And so let me demonstrate that for a moment if that's a little bit out there. I apologize if it is. But let's just open up a basic document over here, make it a little bigger so y'all can see. What I'm going to do is I'm just going to describe the operating system and how Jarvis is working. Okay, so I'm going to go nano test.text just to give me a place to write. And it's just me being silly. Okay, so we're going to call this an agentic OS. Okay, all it is one context document. Okay, the context of that is says, you are an agent part of this structure. Okay, what is the structure? Well, it's a directory. The directory name is Jarvis, and the structure looks like this. So we have the directory called Jarvis, okay? And then you have inside of that, you have a directory called agents, okay? And you have a directory called docs, and you have a global bin directory, and maybe you want to add, something for like environment variables, like, passwords, those kinds of things. Okay, and in the agents directory, I have now a new agent that I've built up, and let's call this agent, 01. Okay, but it itself is its own directory with its own docs, with its own utilities, with its own routines, and its own what else have I been putting in here? Docs, utilities, routines, and logs. Sorry. So that's the operating system. It's that simple. Now, each one of these directories, like this has Jarvis inside this directory at this level, it has a context.md. So when I inject that context inside a cursor or whatever model I'm using, the agent knows that it's part of this system. Now, I also have a context file over here. Okay. And this tells the agent what the agent does, what it's good at, what its utilities are and its routines. And so what is a utility? Well, a utility is really easy to understand. It's just like, let's say I need to check my Facebook messages, right? So I build a script, check, you know, Facebook.sh or .py. I don't, whatever programming language you want to use. Okay. And then what is a routine? Well, it's a schedule. Okay. It's a schedule.py with, basically a code that says, you know, run check Facebook every 30 minutes or whatever your interval is. Right. So these are things that the agent fires up. It does it. It starts the process. So when the agent boots, inside of its context is basically, here's your utilities you have, and here's your schedule. Okay. And the agent then executes the startup routine. It fires the windows. It starts up everything, right? As soon as I run it with that context.md. So let me demonstrate this again really quick. Let's say I go nano, I'm going to call it my context.md. Okay, I'm going to say you're an agent that sends hello messages every 30 seconds. Ensure on boot that you build the script and run it to do this thing. You're sending hello messages in the shell. Okay. So I have that context. Now I fire up the agent and I say I'm going to say agent read my context.md. Okay. And it reads it. Now what's the agent going to do next? Well, it reads inside the context. You've given it an instruction. So will the agent act on that instruction? Right. And you can see like, okay, exploring the workplace to implement the instructions in my context, a shell agent that prints hello every 30 seconds, which is a simple utility and it's a very simple routine. And the agent is going to execute on that. And that is the essence of automation, right? The essence of automation is to take context, inject it into an AI language model that then infers what it needs to do and then does it, right? So you can multiply this out tenfold. You do this thing, do this thing, do this thing, do this thing. And you can give a pretty serious, robust set of instructions with today's language models. Um, and so what I've been building is a way to control that. And that's where I made the comment about Google Skyon and whatnot. I said, well, they're trying to build a system and release it to the public to control it, which is great. But I've also been building this system and I want to share it with you to say, like, well, there's not much of a system. I mean, you have a language model and you have context, and then you need a directory or a structure, right, to organize it all. And the tools to do that are, a multiplexer, which is tmux, command lines, windows, and then a GUI to try and bring it together. So hopefully so it shows you, okay, it ran successfully, it's doing it, it's loaded, it's now printing that out to the agent log, and I better exit and kill the task. So let's go back to my context doc. No, not that. My other one, desktop. So when the agent boots up, it gets the context, it's aware of its utilities, it's aware of its routines, and it goes and does the work. Now, the cool part about this structure is this is a directory structure. I mean, if you go back to Bell Labs, you look at like how they build Unix, it's almost the same thing. It's like, okay, we have agents, docs, bin. Maybe I have libs in the future. Maybe I make it, more complex. And I view the operating system as context, right? And hopefully that's not doesn't sound crazy, but that's really all it is. I mean, if you told an agent that you're an operating system and here's your structure, if you told a language model that, you pretty much have an operating system. The agent knows what to do. Now, the challenge is that you got to keep the agent on task. You can't fill up its context length, and there's mechanisms to deal with that. But but that's all I built. So I built the directory structure, I injected it with context, and then I kind of started layering. I'm like, oh, we have agents. I have agent one. This is its utilities. This is its routines, and so forth and so forth. And what it led to is kind of this system that is all context based. So, if we go like this is just a test agent. It has no utilities right now, but I'm going to say like, can you build a utility to check disk space um and and run it every 30 seconds, send the task to, of course, pane 2. Um, okay, so we'll fire that up and we'll let the agent build that utility. And so what's going to happen is the agent understands how it's supposed to build utilities because it had the context, right? And the context of it is like, it's down here. It basically tells the agent, everything it needs to do. And and so what you're going to see is the agent's going to build that utility, and then I'm using context to store that utility here, right? And the agent has instruction to then write that update to the context file. So the next time the agent boots, well, it knows about that utility, right? So I'll just show you this as it completes. Um, okay, just thinking. I'll just hit refresh on this. The cool thing is when I refresh now too, I don't have to worry about anything breaking because, you know, um, so yeah, I see now it's doing the pane two. It's showing you the task that it's booting, but you'll see down here, here's the utility, right? Now I'll recall this agent, so I'll kill it, and then I'll deploy it again just to show you that in the deploying phase again, what happens is I fire up the agent with the context. Well, the agent reads the updated context and it's going to say, oh, I have this utility, right? That I can check this space every 30 seconds if I want to run that utility. And that's how I like build my control, right? That's how I build like I basically in the context I say agents, you can only do what your utilities are. So a user has to build utilities before you can do stuff, right? So I don't have agents running wild. And it'll work. It works fine as long as I keep watch that context length and that context management. But and then yeah, of course I have it highlighted up when it's running, and that's kind of just a cool thing. So as I dig deeper with that, I kind of wanted to share it, and maybe some of you get it, maybe you think I'm crazy, but I'm looking at the world of AI and I'm like, okay, I need to start managing out scale, right? And so right now I've got like 50 agents doing different things. I built a bit of a management interface that allows me to like supervise them all, figure out what they're doing. Again, using tmux to do the supervision. But this is kind of the UI that I've landed on, which it's not great, but it allows me to visualize, okay, what are my agents doing? And then when they're actually doing something, you know, it actually lights up and shows me that they're working and whatnot. But but yeah, like I thought the community might want to learn a little bit about that. Now, as I go forward, I want to ask you guys something. I'm kind of thinking of maybe offering a couple courses, and I don't want to do it like, the traditional YouTuber way. It just I am a teacher, but I've also worked in this industry for about 20 years now. And I'm pretty versed on every language, and my fundamentals are very strong on DevOps infrastructure and everything else. And I've actually considered maybe building a little bit of a learning platform that's not like I'm trying to do it the right way. And so I'd ask for your feedback on what you think the right way is. But in my mind, it's more like, okay, here's a course, here's a one-time fee for that course, take it. And, you can chat with me a little bit. We can do some one-on-one sessions and just kind of like go about it that way. I'm very much, I feel like my skills are very much one-on-one with people. And so that's one of the things that I'm considering. And I thought, if I kind of gave you a bit of a window into how I'm kind of thinking about AI and coming along as a programmer and understanding, these fundamentals, I actually see that the more people I teach, the more necessary programming fundamentals are for understanding some of these concepts. Like say if I built 30 agents and I need to move data between them all, if you don't have a solid understanding what functions and parameters are, you're just not thinking the right way. Um, Not to say that programmers are better or any of that, like that's not my intention, but programming fundamentals teach you how to think more like machines. And if if that's useful, right? In the age of AI. But I want your opinions on it because there's all this talk right now where AI can code for you, AI can do this, AI can do that. But there's this really interesting part that no one talks about. This will be the final thing I share tonight. I have a robot here. Oh, I'll just take one of my drones. I code through drones all the time. But so you got a little drone like this, right? And you know, I can hook this drone up to AI and it can spin and it can send all the imagery to ChatGPT and then the drone can target me, right? It can infer, I can put all my inference to ChatGPT and it'll find me and I'll say, there's Matt. Now at that point, I can switch from sending and using ChatGPT to programming. I can switch from inferring to running a local program. So what I mean by that is that we often think that, or people are thinking right now that they're inferring everything because they don't want to think about code. So they infer, they ask ChatGPT, do this, do that, do this, do that, do this, do that. Now, the cost of that inference is rising, right? You could read about the Claude news and all this stuff. That cost is rising and it's going to be rising. But it's also a power thing, right? Like think how much power I'm burning by asking ChatGPT to like find me. And what's interesting is once I find it, I can actually switch that code to local, Python code that's like, oh, image detected, and it's just programming. And one of the examples I give in class is like, think about a Tesla. A Tesla drives itself. Is that inference or is that just good programming, right? And so Tesla is kind of the OG of really good programming for self-driving cars, where their inference is they're not really using traditional inference. They're using just really good code, right? And that's why programming is so important, is because we just don't have the power capacity right now to infer everything, right? And even if we did, inference is risky. Models can make mistakes. Models can do that, but not saying like AI is really good. But there is this value where I use AI to build local code sets that makes me so I don't need to infer anything. And that's what I did with Jarvis, right? So Jarvis was like, oh, I'm going to build the utilities, and I'm going to build the routines, and the agent's going to fire up, and I'm going to infer for like 10 seconds, and then all my automation, all my programs are going to take over. And it's funny watching AI kind of wrestle with me on this one because I'm always like, no, build a bash program, build a Python program that does this, just manage it. But AI is always wanting to dispatch so it can burn tokens, right? It's kind of tricky that way. So that's why I think programming is so important, is that we need to understand AI, and the best way to understand AI is building good fundamentals. The best way to utilize AI is to take those fundamentals and understand infrastructure, understand DevOps, understand how to manage servers, right? And then once you have those two fundamentals, let's talk about how we engineer context the best way. And that's really an interesting topic of study. Like if I have this set of instructions and I give it to every language model, is every language model going to execute equally? Right? Not always the case. So so anyways, yeah, I had the kind of fun project that I got the students to build Donkey Kong, and I gave them the weakest model, right? I think I mentioned this earlier, but I gave them the weakest model to build Donkey Kong, and they all didn't build it, and I did. And the difference was is I just engineered the context. I said, you're going to build a game board. It's going to look like this. It's going to do that. Da, 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 da. And all those things came from fundamentals, right? Like understanding, I have to move a piece, right? You have to learn JavaScript to be able to move elements on a page and whatnot. And so, anyways, I thought I'd do a bit of a different video, not BlackBerry related, more about, hey, this is a little bit about some of the stuff I'm working on, some of the stuff I'm doing, and I wanted to gauge your interest if you think there's any interest if I put together a kind of a low cost course about programming, fundamentals if there would be any interest in it. So please give me your feedback. Thanks for watching. We'll catch you in the next video.